All right, I'm starting our recording, class recording. So 2 weeks ago, we took our midterm exam, and then last week I had a power outage on the island here, so I wasn't able to hold class. And I didn't tell you anything about makeup class yet until now. So our makeup class, we will schedule today according to your schedule. We'll talk about that toward the end of class.
Okay.
All right. I didn't mean to delay reporting your midterm exam results, but I just discovered yesterday that you still did not have access to viewing the results, which I was not aware of. So sorry about that delay. It turns out I needed to adjust some of the scoring. One of the questions was bad, so I had to give a point for everyone for that question. So I manually updated the scores. Two of the questions were misgraded by the program because of the way that I set up the answers. So it was my fault. Anyway, I regraded by hand those two items and adjusted everyone's scores. So you should see the correct score now on Blackboard. All right. I just uploaded the slides for this week. This is lecture 7 on quasi-experimental research as a method. All right, so let's get to it. Share screen here. Okay. All right. Here is a side-by-side comparison of exam results last year and this year. Notice that last year the scores were pretty much like a straight distribution from around 50 to 55% on up to about 95%. Whereas this year we got one score of 100%, and then most people's scores fell over 70%. So much higher distribution. I'm not sure if this was a real test taker or not, or an accident, I don't know. But anyway, so the distribution of scores was much higher, and this tells me that open book and optional collaboration were effective at helping you to answer correctly on the exam. All right, so I hope you liked that format. I do have a poll that I want to give. Someone suggested I give a poll about the exam, and I thought that was a great idea. So I'd like to give you the poll right now. All right, I'm launching it, so please take this little survey. It's anonymous, so you don't have to feel concerned or embarrassed.
For the last question, is it asking about like class, regular class?
Yeah, like our class, this class,
Okay.
yeah, or any classes. I'm just curious. Would have been better if we got a more representative survey of more students, but based on the 18 students in the class, we can get a pretty good idea, I think. Okay, well, it looks like we've got just about everyone. I don't know if you can see the results that I can see on my screen. Can you see the results here?
No, I think
No,
you have to share it.
they're hidden. Okay. Uh, Not sure if I can share it. I can definitely tell you the results. So um, just over half, or about half of you felt that, or no, let's see, worked with two or more others. About 25% worked alone and 25% worked with one other. So about 3/4 collaborated, 1/4 did not. Second question, how do you feel about the collaborative option? Uh, Most felt neutral. They liked it, but they had some concern about it. And the next highest option was they preferred it. And then the third question about Zooming, about 50% like the Zoom option. About a quarter prefer the classroom, and about more than a third are neutral. All right, so that was interesting polling results. Thank you. I can share. I had to stop the poll and then I could share the results. So I'll go ahead and share results here. Yeah. So you can just take a brief look. Number one, you like to work alone or with others? Number two, how do you feel about collaborating on exams? And then number three, how do you like Zooming or in the classroom? So fortunately, Zoom is not absolutely hated by most people. It seems that on the whole, it's slightly preferred or neutral. All right. Thanks. Let's go on. Okay, so today's class topic is on quasi-experimental designs. These are the designs that are similar to experimental design, but the quasi element means that it's not actually an experimental design. Quasi means nearby, next to, approximately, in the general neighborhood of, but not exactly the same. Quasi means not quite, or it means somewhat. So a quasi-experimental design is not a true experiment design. The only difference between a quasi-experimental and a real experimental is the quasi, you do not assign people to conditions. People are already assigned to conditions by the time they get to the experiment or when they participate in the experiment. They have already been assigned to condition by their birth by nature. For example, if I wanted to compare left and right-handed people, some would be born left-handed, some right-handed, or they would, if not born that way, then they would have decided by themselves that they are right-handed or left-handed before they came to the experiment. Same thing for male and female. You're not assigned to those things usually during an experiment. You come already having been assigned previously by nature or whatever. Okay? So quasi-experiments are those in which the participants have already been assigned before the experiment begins. When I say assigned, I mean in your quasi-experiment, you have conditions like an experimental group and a control group, or this group and a that group. So the this and that could be, if you assign them randomly, that's an experiment. But if you cannot assign them, then it's a quasi-experiment. All right. That's basically what quasi-experimental design means. Now let's look at this example. What's the effect of political view on gun control options? Now, the phrasing is, what is the effect of? Now I ask the question, are we really measuring the effect of? And the answer is no, we are not. Why is that?
Is it because we can't control who's going to be in what political view?
Exactly. Because we cannot assign our participants to be conservative or liberal. I mean, maybe you're lucky and you can find enough participants who are absolutely neutral, absolutely neither conservative nor liberal, and then assign them somehow. But how do you really convince them to become conservative or liberal? These political positions are kind of deep rooted, rooted in uh, strongly held beliefs and values a lot of times. So we can't really adjust people from one group to the other or vice versa. We can't really push people one direction or the other. So people come in and they're already conservative or liberal. So if the research article is titled "The Effect of Political View on Gun Control," that's misleading. We cannot measure the effect of a quasi-experimental variable. Because we cannot separate the effect of a quasi-variable from many other possible variables. Are you in favor of gun control, meaning that you think there should be a lot of laws and regulations about owning a gun? Is that attitude because you're a conservative, or is it because of any number of reasons that are correlated with conservatism? Maybe the location that you live in, maybe maybe many things. So you cannot say, firmly conclude that it's because you're conservative that you have this opinion. That's a causative explanation. That's saying that A causes B, but we don't know that because we cannot assign people to conditions all we can say is that there's a correlation between a quasi-variable and some measured outcome variable. So when two things that you did not assign go together, they're correlated, but we can never understand whether there's a causal relationship, whether A causes B, or if they're simply correlated together. The reason we cannot separate those two possibilities is because we cannot separate the person from their condition. The condition is their political view. We cannot take the person and their political view and separate them, because the person and their political view come together attached. They're stuck together. And when you have a trait or a characteristic that is stuck to the person, that's a quasi-variable. And you cannot assign that variable. You cannot separate the variable from the person. So you cannot establish causality. Does that make sense?
Yep.
All right. Any questions about that? Okay. The next few slides are going over group designs, quasi-experimental designs. So these are like vocabulary words for you. They are designs that you might wish to use for your study, but they seem uncommon in the research projects in this class. Still, I welcome you to consider using any of these. These are pretty good designs. All right, so here's the first one. One group pre-test, post-test design. One group, so there's no dividing people into groups like conservative, liberal, no. You just have one group, you test them, then you give them a treatment, and then you test them again. So the pre-test is before treatment, the post-test is after treatment, and then you compare the test results. You can subtract to find any difference. If you find some difference, it could be because of the treatment. For example, let's say we take a group of smokers and we give them a smoking, patches to put on their skin, nicotine patches, and we see, does that help them reduce smoking? And then we test after the patches. So 1 week of patches, and then we can test how much they smoke before and after this 1 week. That's a pre-test, post-test design with one group. We can consider the pros and cons of this. What are some disadvantages of this method?
Would it be similar to the disadvantages of a within groups study?
Exactly. Well said. Just as any within subjects or within groups design has the problem of practice, by the time people take the second test, they've already practiced on the first one. So you don't know if they're getting better because they took the test earlier. They're learning how to do better on that test. So smokers might realize that they can achieve a better score on the next smoking test if they smoke less. So there's these kinds of effects. The effect of the first test on the second test. So we cannot separate the effect of the testing from the effect of the treatment. That's a really good explanation that you gave. Thank you. All right. So that's the one group pre-test, post-test. Then there's the interrupted time series design. This is also a within groups or within subjects design, where we test every single participant not only twice, but 3 or 4 or more times. Usually you have 2 measures before an intervention or a treatment, and then there's the treatment right in the middle, and then you test at least 2 more times after that. So you've got test, test, treatment, test, test. So you can measure, is the improvement due to the treatment or is it due to being tested? If you can see that improvement, like test 1, then test 2 gets better, test 3 better, test 4 better, you can see that there's a gradual trend of improvement, then you could say, it's because of the testing itself. But if you see there's like no difference between test 1 and test 2, and then treatment happens and there's a sudden improvement, then not much change between test 3 and test 4, then you could say, this interrupted time series shows us it's not the effect of the testing, it's the effect of the treatment. So it's a way of differentiating between treatment effect and test effect, or the effect of time. Any questions? This is illustrated here. Okay, so here's a graph of the one group pre-test, post-test design. We can see the change here could be due to the treatment. The treatment happens between these 2 tests. Here's an interrupted time series where the dotted line down the middle is the treatment, the time of the treatment. So on the bottom axis, there's the time 1, time 2, time 3, time 4, or test 1, 2, 3, 4. And we see some improvement between test 1 and 2, a bigger improvement between 2 and 3, and some decrement between 3 and 4. These are just made up data to illustrate the effect of the treatment and maybe the effect of testing. Any questions?
Okay. So there is a treatment between test 2 and 3, or there are no treatment in this data?
There's the treatment right between test 2 and 3.
Okay.
So we can infer that the sudden rise in the score between test 2 and 3 could have been due to the treatment, was probably due to the treatment. That's what we would conclude. Thank you. Any other questions? Okay. Now we move on to non-equivalent groups design. This is a bit of a confusing word, non-equivalent groups. What is it talking about? It is talking about groups that are not matched. Now, if groups were perfectly matched, it means that group A and group B would have the average age the same, the average intelligence the same, their race and religion and their physical abilities and everything would be the same. But we cannot match group A and group B perfectly on everything because we don't know which variables to match them on. So there are too many variables to match everyone on, and we don't know which variables are important to match people on. So if we recruit two groups of people in a quasi-experimental design, the two groups of people are virtually always non-equivalent. So when we say non-equivalent groups, all we really mean is two groups or more. All we mean is groups in a quasi-experiment. So that's what non-equivalent means. All right, next we've got post-test only non-equivalent groups design. That means that we take two groups, we test them both before and after treatment. Hold on. It means one group gets the treatment and one group does not. Both groups are tested before treatment and both groups are tested after treatment. If we expect the treatment to work, we should see only the group that received the treatment should improve between the pretest and the post-test. The control group should not improve between pretest and post-test. Oh, I'm sorry, I misread this. It says post-test only. Okay, so for the post-test only, we're only comparing performance between two groups, the experiment and the control group. The next one on this slide is the pre-test, post-test, non-equivalent groups design. And that's the one I was talking about, where so both groups are tested before and both groups are tested after. The experiment group gets a treatment, the experimental treatment, and the control group either gets nothing at all or they get a sham treatment. A sham treatment is some treatment that is made to be closely equivalent to the experimental treatment without having the key ingredient, that key ingredient, which is the experimental variable. So for example, in a pre-test, post-test, non-equivalent groups design, we might take 5 smokers and 5 non-smokers. The 5 smokers get patches, nicotine patches, for 1 week. The 5 non-smokers, sorry. 10 smokers. 5 get a nicotine patch, 5 get a fake patch. All right, so all of them are smokers, but half of them, I see. Okay, hold on. Sorry, I'm getting a little confused here. To be non-equivalent groups. Okay, yes, it is getting complicated. The non-equivalent groups means one of the variables that you're studying. So one of the variables is smoking. You'd have to have one group smoking, one group not smoking. Those are the non-equivalent groups. And the pre-test, post-test means you test both of them before treatment and after treatment. You can add another variable if you want, treatment being a sham or the real treatment, but that's another variable. All right. So to make it not too complicated, let's ignore that other variable for a moment. Maybe it'll be easier to understand when we look at the graphs here. All right, so here's the post-test only on the left. And the non-equivalent groups you could think of as smoking group, group A, and non-smoking group, group B. And you can see that the smokers smoke more cigarettes per day. All right, so there's no treatment here. It's just a post-test only. So obviously there's going to be a difference between groups because you selected groups based on their quality or their character, smoking or not smoking. All right, then here we've got the pre-test, post-test, non-equivalent groups. And in this one, we have a treatment. So in the post-test only, there's no treatment. But in the pre-test, post-test, between, there's a treatment. So there's a treatment between the blue and the orange bar. We could call this let's say I'm trying to make up a variable on the axis. Let's say number of ice cream scoops eaten in the week. So if we measure ice cream among the smokers, before we give the test, they ate 3 scoops of ice cream per week. And then after the smoking patch, wearing a patch, a nicotine patch, at the end of the week, they ate 4 scoops of ice cream per week in that week. Whereas the non-smoking group, group B, you measured they had about 2.5 scoops of ice cream. And then after their wearing patches, they eat 3 scoops of ice cream per week. So the increased ice cream consumption, it could be because of wearing a patch, nicotine patch, or it could be not related. We don't know. But we see that there's greater increase in ice cream consumption among the smoker group. All right, I feel like this is a pretty strange, contrived example, but I am trying to give an example of trying to illustrate pre-test, post-test, non-equivalent groups. Not sure if I've made it clear with that example. Okay, let me think about this. Okay, I don't even have to think about ice cream. We could go back to smoking cigarettes. I was trying to make it sensible because the bar graph increased at the post-test instead of decreasing. But you could think of it as cigarettes smoked. So after they're wearing a patch, they smoked more cigarettes. That doesn't make sense, but just for looking at the graph, you could see it that way. So in between the blue and the orange bar is the intervention. And we test every group twice, once before the intervention and once after the intervention. Any questions?
So the reason why it's a quasi-experiment is because we aren't randomly assigning people to the control and the experiment?
Yes, that's right. Thank you. That's a good way to summarize. All right. The next slide is just continuing the same concept, but then adding another characteristic, switching the replications. Switching replication. So basically, you've got your two groups. We could have any number of groups. We could have 3, 4, 5. Let's just work with 2 for simplicity. So we've got 2 groups, and let's say we test them 3 times. On the previous slide, we tested them twice. You could see the pre-test is blue, the post-test is orange. Now we're going to test 3 times. We have a test before treatment, a test after treating the treatment group, and then a third test after treating only the control group. Now you might think, come on, they're a control group. You don't treat the control group. That's why they're called a control group. But in this case, the control group is treated. They're just treated later in time. So at the first test, no one is treated. At the second test, the treatment group gets treated already, and then they're tested. And the control group is also tested, even though they have not yet been treated. And then finally, by the third test, we test the treatment group again and the control group again. But in this third test, the control group has now received the treatment. So both groups received the treatment by the end, but the treatment group received it before their second test. The control group received it before their third test. So all the groups received the treatment, and all the groups were tested before and after. But we can see the timing of the effect. We can see that timing of the effect and how it correlates with the timing of the treatment. And that's going to be illustrated on the next slide here. All right, so just take a look at the left panel. This is the pre-test, post-test with switching replication design. So we've got the pre-test where you have, let's call it smokers and non-smokers. Smokers smoke more cigarettes. It's kind of weird to call it number of cigarettes. Maybe we could change the variable to something that makes more sense. Let's see. Try to come up with something that makes sense here. Okay, let's just say depression scores. So on the y-axis is depression scores, how depressed people are. All right, so smokers and non-smokers. All right, then, oh shoot. We don't want depression scores going up after treatment. Okay, so let's change that to optimism scores. All right, so after the treatment that is given only to the smoking group, given illustrated with that blue dotted line. All right, so only the blue group, group A, the smoking group, only the smoking group gets the smoking cessation or the nicotine patches or counseling or something. All right, so then when you go from pre-test to post-test A, you can see that the smoking group, the blue bar, rises because they're rising in optimism. But you see group B, non-smokers, they also rose, their score went up a little bit. That's just by chance, by practice, or by time. So we can see there's some difference between pre-test and post-test A. But the bigger difference happened for the smoking group. Now, let's say we give the same treatment, let's say counseling. We give that to the non-smoking group. And we measure optimism at post-test B. And we find that in post-test B, the non-smokers went higher in optimism from their post-test A, where they did not receive any treatment yet. You can see that orange dotted line indicates the treatment for the control group, group B. And when you give the treatment to the control group, their scores go up. But you're not giving the treatment to group A. Between post-test A and post-test B, there's no treatment for group A. So their scores don't go up. They go down a little bit, just with the passage of time. So you can see that the effect of the bar difference in height, or the optimism score change, is highly related to the treatment, because the treatment boosts the effect of the blue bars. That blue dotted line boosts the effect of the blue bars, and the orange dotted line boosts the effect of the orange bars. So we can see from this bar graph that the effect of the increase in the bar height seems to be most strongly correlated with the treatment, not with the passage of time. Do you see that, or have I confused you?
No, like it's okay. You're not
Okay.
confused.
All right, going back a slide. Now we are going to the switching replication with treatment removal design. So this is the same as the above, but now we have a chance to switch the control group with the treatment group. I'm sorry. We have a chance to remove the treatment from the treatment group and from the control group. And I will just explain that on the next slide with the graphs. Basically, you're going to test 4 times. The first time is you treat everyone before treatment. So that's the pre-test. Then you give a treatment to the experimental group. So the treatment comes between the pre-test and the post-test A. So there's a treatment there. So you measure the effect of that treatment on the experimental group. I'll go to the next slide. So here we have some small difference between the quasi-experimental variable, the 2 groups, let's say smoking and non-smoking. Then you give a experimental treatment to the smoking group. So that then seems to increase their scores. We might see some small improvement in scores in the non-treated group just by accident, by the passage of time, or by practice, or whatever. Then we have this dotted line here to indicate removal of treatment. And we have this dark orange line to indicate adding the treatment to the control group. So now the orange group gets the treatment, while the blue group that had the treatment, that treatment is removed from them. If they were already receiving some counseling, now they stop receiving counseling. So you can see from this bar in post-test A, the blue one, to post-test B, the blue one, there's a reduction in their optimism. But Group B, from post-test A to post-test B, increases optimism because they received their treatment, which we could call counseling. So we can see a reversal of the effect. The treatment effect is reversed. In one, the effect is applied, the treatment is applied to group A. Then in post-test B, we remove it from A, we add it to B, and we see that reversal effect. Positive effect for group B, but not A. And then in group C, we remove the effect. Sorry, we remove the treatment from group B. So now we have removed already the treatment from both groups, and we can see this post-test is the effect, or this is the measurement after we have removed all of the treatments from all the groups. Does that make sense? Or have I confused you?
It makes sense.
Sense.
Okay, cool. This is kind of complicated stuff, and I had to use a lot of verbal explanation, and I catch myself misspeaking and correcting my words, so it's quite a little bit hard to follow, but I hope you got it. I hope the diagrams help to make sense. And this is a rather short lecture today because we need to spend some time on other things besides lecture. So this is the conclusion for this lecture. The conclusion is this: although quasi-experimental designs cannot be used to determine causality, the complex designs outlined just earlier can strongly rule out confounding factors, especially applying and removing treatments and comparing with control groups or other treatment groups. So I'm going to just flip back to show you again. If you just look at the blue bars on the left graph, this is before treatment, after treatment, and orange bar, before treatment, after treatment. We're looking at the effect of treatment in both groups, the experimental group and the control group. And then in the right graph, we have the effect of experiment going from blue bar to blue bar and pre-test to post-test A. So we can see the effect of treatment. Then we can see the effect of removing treatment as we go from blue bar, post-test A to post-test B. So we can see how removing the treatment affects people. Again, this is showing the effect of treatment. First, we had the effect of treatment by adding the treatment. Now we see the effect of treatment by removing the treatment. If we see the effect of removing treatment takes people's scores back down, then again, we have double evidence. Evidence of the positive effect of treatment, and now evidence of negative effect of removing treatment. And those two pieces of evidence together, combined, make a very strong argument that the treatment is real, because we have the effect of adding it and the effect of removing it. If the effect of adding and the effect of removing can be witnessed in the data, then you have concrete, good, strong statistical evidence that the treatment has a real effect, because you can see the effect by adding it and by taking it away. So you have two pieces of evidence. Then we can have the same thing going on in the control group, group B, where we see not much change between here and here because there's no treatment. Between pre-test and post-test A, there's no change in the control group. So not much difference. Then from post-test A to post-test B, we see a big effect in group B because we have applied the treatment. And then we take that treatment away between B and C. We can see that post-test B to post-test C, we've removed the treatment and the positive effect of the treatment goes away. So the counseling, take the counseling away, and then the optimistic effects go away as well. Something like that. We're just making the example up so that it makes sense. All right, so yeah, that's our conclusion. That these complex designs assist us to make conclusions about causality, because causality is hard to prove when you use quasi-experimental variables or a quasi-experimental design. It's hard to prove causality. So we use these complex designs that assist in providing evidence for causality. And with these designs, we improve our ability to make a causal conclusion. So when we increase the ability to make a causal conclusion, a conclusion about causality, we increase the internal validity. What we call internal validity is improving our chance to make a conclusion about what causes what. So internal validity is something that we want in experimental designs. So when we go with a quasi-experimental design, we need to do something special to increase the internal validity so that we can still make a causal conclusion from the data that we collect, from our results. Okay. Maybe we should take a break and then come back to our practice. So let's take a 5-minute break. Since there's fewer people in the class, we'll take a shorter break. Come back at 2 o'clock and we'll do these exercises.
Okay.
Welcome back from the break.
We're back.
So let's get started with these exercises. One moment. Okay, so you can read this. This exercise we'll do as a class because I need to read to you what these things mean. Regression to the mean, spontaneous remission, history, and maturation. All right, so basically, first of all, we've got this group of kids. All right, so we've got a group of fat kids. And the program is an exercise program. And their weight is measured, then they're given the treatment, and then their weight is measured again. So if we're gonna give this design a label, the name of the design is one group, pre-test, post-test design. All right, now, what are these words? Regression to the mean. I have labeled the words here underneath the slide in the notes of the slide, so you can read that. I'll read it to you. Regression to the mean obesity can vary naturally over time. Recruiting only obese children at time 1 captures some that will stay there and some that will revert back closer to the mean as part of a natural rhythm of variation. So when you selected fat kids in the first place, you didn't know whether those fat kids had always been fat, had recently become fat, if their fatness was stabilized or temporary. If you selected some of the kids who were temporarily fat, then they would, by definition of temporarily, they would revert back to the average weight or their own average weight, which would be skinnier. But you don't know that, right? You don't know which ones are fat for years or fat for only recent weeks or months. So the lesson is, if you're going to recruit non-representative sample, you need a control group. The control group should be equivalent to the treatment group to permit natural observations that would reveal natural regression toward the mean. I need to explain that better, but one moment. Extreme members regress toward the mean faster than less extreme members. A rubber band that is stretched more than other rubber bands will snap back to its original state faster than other less stretched rubber bands. So the more extreme your observation at time 1, the more likely that those extreme measurements would be less extreme at time 2. Because if you're selecting groups based on the extremity of the measure, you're selecting non-representatively. All right, I know that I explained that in really complicated terms, so I'm going to try to make it simpler now. Regression to the mean, it's like this. For example, how many hours of homework do you have per week? Let's say that you are, on average, you have 5 hours of homework per week. But if I measured, let's say I want a heavy homework group and a light homework group. So I select the heavy homework group by asking everyone, all right, how many hours of homework did you have last week? And the heavy homework people, they might have had like 15 hours of homework that week. That doesn't mean that they always have 15 hours. It could mean that they just had 15 hours just that week. And because I don't know that, I might be misled to believe that the 15-hour average group are just heavy homework kind of people. But in fact, there may have been something unusual about that week or about that group that temporarily spiked their homework up just for that week. I don't know that. I don't know what's the reason why my heavy homework group was a heavy homework group that week. I don't know the reason. But if I selected them based on how much homework that they had, I'm not selecting randomly. I'm selecting non-randomly. And I don't know what caused them to be in that heavy homework group to begin with? What caused them to have a lot of homework, that group? I don't know. But if I select them for that quality, it's non-representative, and there's no guarantee that they are stable. They could spontaneously go back down to average the following week. So we need to be very careful in our assumptions about extreme groups. So if I were to measure obese children in one, select a group of children that are obese and give them a treatment, I'm not really guaranteeing that the effect will be due to the treatment. It could be due to simply going back to average, because some people that were accidentally fat at time 1 would have returned to their normal baseline in time 2. So that's called regression to the mean. When people, on average, they go back to the mean. Regress means go back to the mean. Because over time, we go up and down, up and down. And if you select people based on up, that doesn't mean that they're always up. Natural variation is up and down. Everyone goes up and down in everything. So up and down about homework, up and down about weight. So you have to be careful when you select people for being up in weight or up in homework. That's not a guarantee that they're going to be there forever. They could be there temporarily. And if it's just temporary, then there's this effect called regression to the mean, where people go back to their average baseline. Sorry to explain it so wordily with so many words, but I worry that that's a complicated concept. So so just number 1, regression to the mean, how would that affect the results? Anyone?
I mean, I guess maybe their weight might go down, and not because of the physical activity program, but because they're just regressing back to the mean. I mean, especially if they're children, then I'm pretty sure that their weight can change quite a bit. I mean, we have stuff like baby fat,
Mhm.
right?
Yeah.
So maybe it's
Maybe they
that.
hit puberty, maybe they have a growth spurt, maybe they have an intestinal worm, stuff like that.
Very good. Next one is is spontaneous remission. Let me read about that. Spontaneous remission happens without treatment. Some people will be reclassified from problem condition to no longer having the problem condition. And that would happen spontaneously without any understood mechanism. We don't know how it happened or why it happened, it just happened. So that happens, and that's called spontaneous remission, when we don't know the reason for it. So because of that, we need a control group that is as close to equivalent as we can get. So if we're measuring cancer recovery, we might have some people recovering from cancer spontaneously without any kind of treatment. They can become cured, and we don't know why. So because of that, we need to have people with cancer who get the treatment, chemotherapy, and then people with cancer that we do not give treatment to, they do not receive chemotherapy. And then we can look at the remission, and we expect maybe if there's going to be some spontaneous remission, that it would happen equally in both groups. So we expect a little bit of spontaneous remission in both groups, but the treatment group should have more remission. All right, so in this example with obese children, how would spontaneous remission affect the results?
The results might make it seem like they lost weight because of the physical activity, but it's just spontaneous remission because of something, and we can't really measure.
Exactly. Thank you. Third one, history. Whenever there's some newsworthy event that happens between the pre-test and the post-test, well, is it the effect of the treatment or is it the effect of the news or whatever history occurred in the world or in your village or in your home or in your personal life? All of this is history. The history of, basically, it just means time. So how could time affect the results of this study with the obese children?
Chance for random variable to occur.
Yeah.
Or maybe maybe this study is happening during a time where food isn't plenty.
Mm-hmm. Good. If you're measuring obesity where there's a food shortage, there's a sudden food shortage, you don't know if this is the effect of some historical event or the treatment effect, as an obvious example. All right, the last one, maturation. That's where over the course of treatment or testing, some of the participants mature, they grow up, either in their mind or in their body. Let's say they grow up in their mind and they figure out, I understand what the whole treatment's about. Plus, I understand how I can treat myself in more ways than just that. So once people mature and start to gain greater control over their life in various ways, whether it's coming up with extensions of the treatment on their own, or due to physiological changes in their body, maybe some hormone starts to take over or be produced, and that changes the whole internal biological environment. This could have some effect on the experiment. So how might maturation affect the results of the obese children study?
If some children are already in the progress of losing weight, then the treatment doesn't really work. It's the process that has already been going on.
Right. It's possible to lose baby fat simply by puberty or other kinds of hormones and stuff. Right. Good. Okay, so that's just helping us to understand what these four terms mean and in an applied sense. Okay, next practice exercise. This is, I think, all right. Read this example. So imagine there's two courses, section 1 and section 2. All right. Section 1 gets quizzes throughout the whole semester. Section 2, no quizzes. And then they all take the same final exam.
I think maybe perhaps stress. Perhaps one group's more stressed than the other, and that might affect their performance in the final.
Very good. Okay, so I'm going to write that down.
I know it affected me.
right?
Or maybe the two sections have, like, since the teacher is different, maybe their intelligence is different, like IQ.
You mean the intelligence of the teachers or the students or both?
No, I think both, and especially for the students overall, maybe one had a higher IQ overall.
Yeah, intelligence of the group tested and of the professor. Professors. Good. That's a good one. Can you come up with some
Studying
more?
technique employed by a student outside of the class.
The study techniques employed, right?
Yes.
Good. That's right. Anything else?
Maybe the teaching style of the professors.
Yes. Yes. That's right. That is a confounding factor. And one more. How about like a placebo effect or an expectancy effect? I'm just going to write that. Expectancy. It might be that those who got the quizzes expect to do better because they think that quizzes help them do better on the exam. That might be the reason for the effect.
And maybe the professor in the test effect started teaching better because he expects them to do better.
Good point. So we could have that from the students' expectation or teacher's expectation. Does that make sense?
Yep.
All right, so there are confounding factors when we have a kind of non-equivalent groups design here. Why is it called non-equivalent groups?
Because the two
Yeah,
group is not randomly assigned.
That's
the two
right.
class.
Perfect. Non-randomly assigned. That's right. Okay, so that's the end of the practice. Now we go to choose your study design and choose your materials. Select your materials, whether they are existing or novel. If they're existing, it means you have to find some scale or something that you can use to measure people that's already been created and invented. Whereas novel means you're going to generate your own kind of measurement device or test. So it's up to you. So which design you use is also up to you. You can use one group before the pre-test post-test or two groups pre-test post-test. You could do a interrupted design. You could do treatment removal. You could do correlation design, experimental design, quasi-experimental design. Anything that I've taught you so far, if whatever makes most useful sense for your project, your research question, you get to choose it as a group. You decide, you make your design, you choose your materials. Then I will review your materials prior to your data collection. I will be the IRB, which means I will be your institutional review board. I am a one-person board committee. So then you're going to submit your materials to me, and if relevant, describe your procedure to me, and I will then judge it for ethics and relevance, suitability to answer your research question, and after I give you the green light, which means I approve your design, I say this is good, I like it, then you can collect data. Now we can schedule you before I approve your group's design and project materials. But if I don't approve your materials in time, then we will have to reschedule for a later data collection date. I want 4 groups to collect data each day. I'm going to have like 3 days of data collection, and your classmates are your participants. Do you have any questions about this?
I actually have a question. Where should we submit it?
Maybe by email to me. I think that would be
Okay.
best. Email me your materials. Thank you. Yeah, that would be good. All right, next slide. If you're ready to be scheduled for data collection, then I can write down your name, your group number, if you have a group number. So I have decided, following our syllabus, we're starting data collection next week. And then I want us to have a makeup class, maybe March 26th, but I want to decide that with you guys now. And then March 30, another data collection. So let's talk about makeup class.
We won't be free on March 26th because in the morning we have an exam from 9 to 11. Then in the afternoon we have class.
Okay, that's what I wanted to know. I wasn't really looking at your schedule, so I don't know what your schedule is like. Can you guys look at your schedule and tell me when could we do a makeup class? Is there any time between March 23 and March 30?
For March 23 and March 30,
Or it could be later than March 30 if you need to.
I mean, we're free in the morning for March 22, which is Monday, because in the morning we won't have class for that week. But other than that, we're only free in the morning of Tuesday.
Uh-huh. Did you say Tuesday?
Yeah, like today, because we don't have class in the morning.
Okay. Let's aim for, okay, you said you don't have class on the 22nd. What about on the 29th? Do you have class in the morning?
29th, yeah, we do, because we have like one class with video Zoom, then the next class we don't have Zoom, and it keeps repeating.
I see. Well, then
Yeah.
we should do March 22.
Okay.
Okay, so let's schedule that. Okay. All right. So let's get between March 22 and March 23, let's get a total of about 10 groups. And then, so most everyone will try to schedule people for these dates. And then if you're really not ready, if you can't be ready in time, well, just let me know and I will move you down to March 30. All right, so who's brave enough to commit to or pencil in March 22 as your data collection day?
I mean, our group can.
Okay, so March 22 a.m., March 23 would be p.m., March 30 would be p.m. And what this means is March 22 at 9 a.m., we will have a makeup class. That means from 9 to 12, potentially from 9 to 12, we'll be having class. I will have my lecture from 9 to 10 or 10:30 or so, something like that. From 9 to 10:30, and then from 10:30 to 12, we'll have data collections. Groups will pass out or distribute somehow. They will give their materials, their surveys or their experiments to the rest of the class, and you have to do that online somehow, either by sending me materials in advance, then I can post it on Blackboard. That's one way. Or emailing the materials to me and I email it to the class is another way. Or you could email it to the class directly. Or you could put your materials on a online Google Forms. That's a very useful technique. And if you put your materials on Google Forms, then you can post a link to your Google Form document in the chat box in our Zoom class. That is a pretty strong idea. I like that. That's a good strategy, good approach. So that's an idea. I'm just brainstorming ideas. Okay, so March 22, makeup class day. Groups. Who wants to go on March 22?
I mean, we can go, but I'm not sure about my group number.
Okay, I'll just put your number. What group number? Oh, you don't know? Okay.
Anyone else in my group know what group number we're supposed to be?
I'll check real quick that out.
I think I can pull up the group numbers right here. Give me a moment. Okay, group 1 is Bambi and Grace. Group 2 is Josh Dane Tripp. Group 3 is Mai Nui Pranam. Group 4 is Rarin Eiko Piper. Group 5 is Cake and Prim. Group 6, Mudme Ploy Plus. Group 7 is Pressy Cat. Group 8 is Bookmate Earl Opal. Group 9 is Bam Bam Ning Ning iPod. Group 10 is Ice Chain Jam Jam Sassy. Group 11 is Natty Chamchun Annie Prim Jazzy. Group 12 is Mokchi Pin Pin Namking Kung. And group 13 is Ing Pun Beo Ping Gang Group 14. Okay, we have a lot of groups. We have Blink, Sandy, Pond Famous, Choi, Bruce. We've got group 15, Parapeak, Nam. Group 16, Fa, Gianna. Group 17, Frang, Giai. So we've got 17 groups. Okay, I thought we only had 12. That was my bad. All right, so we need a lot of groups to collect data each class period.
So I was in group 2, so we can volunteer for March 22.
Thank you. All right, so more volunteers. Sign up for groups for March 22, 23, and 30. When do you want to collect data?
I think we might have to make an announcement to the rest of the class.
Maybe I should just assign people.
Maybe.
Yeah, because
Yeah.
March 22 and 23 is a small difference. It doesn't matter much. I think I'll do that. I will assign everyone to groups. Yeah, I will do that. So I will
Yeah,
send an
I guess that
email.
works.
Yeah. All right. So I'm gonna randomly assign everyone to a data collection date, and I'll email that to you guys. All right, the last slide is group consultations, where I'd like to meet with groups over Zoom today, or meet with groups somehow. Could be by phone call or Zoom or somehow. Because I would like to discuss with every group your answers to these questions. These are the important questions that I need to know. You need to finalize and explain to me so that I can approve your materials and your design and your procedure, so that I can make sure that you can answer your research question. First question is, what is your research question? What's your design? What are your independent and dependent variables? That means, what are you manipulating? How are you grouping your people? What are you using to predict your results?
I mean, for our group, we kind of just discussed online a few minutes ago, and we pretty much have an idea. Can we, like, are we supposed to just tell you here right now?
No. So somehow I need to meet privately with your group only. And then the next question, what materials would you like to use? So come up with your materials as a group. And if you give me satisfactory answers to all these questions, then I give you my thumbs up, my stamp of approval. And then you are prepared and ready to, well, you need to be prepared to distribute your materials to the class. And that's happening in 1 week's time. The reason it's so rushed, I know it's quite rushed. And if you need more time, we can give you more time. But if you're ready to collect the materials within 1 week, that would be great. The reason is it gives you more time to analyze your data, look at it, average it, do things with the data, visualize it. The sooner you collect the data, the less long you have to worry about collecting the data. So as soon as you can get your materials and procedure all kind of finalized and ironed out, and I can approve it, then you can be one of the earliest data collectors. Okay? So you're going to be collecting data from your classmates, and you're going to start to do that at our makeup class Monday. I will email the class about this. Monday morning makeup class, 9 o'clock in the morning. We'll have our makeup class that day. We'll have some data collection. Then Tuesday, we'll have another class and data collection. And then March 30, the following Tuesday, we'll have another data collection. Hopefully by then, everyone will have already collected data, and you can just start to work on and analyzing and start working on other parts of your paper. All right. By now, everyone has already submitted your first draft of your paper. And I started to look at and give feedback to the different groups on their first draft, the introduction section of your paper. So far, it's looking kind of good. Some groups better than others. I've only read a few papers. So I'll keep reading through, and that'll give me a better idea of what you're planning to do. Okay, I'm just coming up with an idea right now. Instead of meeting with me on a Zoom audio call, I think I will
Email you, I guess.
email the groups. I think that's what I'll do. I will email each group asking you to communicate, give me the answers to these questions. Yeah, I think that's going to be the best way. So just wait for an email from me. I'm going to email you asking you, your group, these questions. All right? Okay.
Okay.
All right. That'll give you guys a chance to think about these questions. So by the time I email you, you can either, I mean, ideally you discuss with each other. So how do we do this? Well, there can be some email dialogue. Maybe you email me answers and I will ask you questions back and say, okay, well, how are you doing that? And I'll email you back, and then you, through our dialogue, we might be able to kind of collaborate, me with your group, to sort out and iron out what you're doing. So I guess this will require a lot of emailing back and forth this week. So I will plan for that now, and you plan for that, and we will get organized by email this week. All right. I think that's that. So we're doing email consultations. And all right. This will,
Emails today?
yes. I will email you guys today.
Okay.
Thank you. All right. We're getting, all right. I know that you guys are kind of busy with exams and stuff, but this is that organizing time where you kind of have to put a little more focus and emphasis on this class again, so that you can be prepared to start collecting data. All right, so I think this is all going to work out. If you need more extra time, if your group needs more time and you're really like not ready to collect data next week, we can have data collection in 2 weeks time. So that is an option for you guys. All right, I think that's it. Thank you guys for coming to class today. You will have a assigned reading this week. So in case of a quiz next week, be up to date on the reading. All right, kind of a lot of work then for this class now. Sorry, it's a bit heavy. If it's a bit heavy, if you feel overwhelmed with the workload this class for this week, let me know. See if I can do something for you. Maybe I can shift things around, but otherwise that's the schedule. And I think that's it. Any last questions or concerns? All right. It's possible to have a quiz next week. I'll think more about that. All right, anyway, that's all for class today. Thank you for coming, and see you. Bye.
Thank you.
Thank
Thank
you.
you.
Thank you.
Welcome.